Hey, this is PFG.Live, the podcast of the machinists, by the machinists, and for the machinists. Happy Sunday. Welcome aboard. We got a bunch of really cool people in the chat today. Let's see. Robin is here. Welcome aboard, Robin. Evils reports something in the Ghent of the Belgium. Lots of zeros in there. I can't fix those sensors. Josh is reporting in from southern Manitoba, where it is smoky and hot. They have a bunch of wildfires going on. He's reporting winds 250 at 09, gusting to 15, temperature 29er, dew point 13, and with some kind of remarks that I can't read. DBX is with us somewhere in the vicinity of White Plains Airport, where he reports winds are 280, 10 gusting 22, visibility 10 miles, broken clouds at 6,000, temperature 16, dew point 04, altimeter 2971. Dale from Widget Works is mostly sunny from the Edmonton of the Alberta, Canada, where it is 14 degrees science, 28% relative humidity. Bill Olney from Rome, New York, the home of Air Force Research Labs, says the weather is 57F and 16 miles an hour. Michael Juan, welcome aboard, sir. 16 degrees, Charlie, in cloudy Pittsburgh, Pennsylvania. Ted Hyde is with us from Cassafrog. Hey, Ted. From Eustis, Florida. He is reporting from Kilo Lima Echo. Winds are variable at 4 knots, visibility 10 miles, clear, temperature 29er, dew point 17, altimeter 2997. Over on the YouTube, Carl is with us from the People's Republic of Rhode Island, where it is 63 degrees, cold and gray, of course. Let's see. Engineer raised in Kingston. Welcome aboard. 20 degrees science in Kingston, London. Welcome. Threatening to rain, but that's an empty threat. Let's see. Test Room 2003. Welcome aboard, sir. He says, good evening from Oostkapelle, Netherlands. 20 degrees C, where it is always standard and 59% relative humidity. A little moist. Let's see. Harvey Newman is checking in from Santa Rosa, California, where it is 68 degrees. We're standard everywhere. 68 degrees Fahrenheit and beautiful. Welcome aboard, Harvey. Kyle Kirsch is with us from Salem, Oregon. 62 degrees Fahrenheit, on its way to 85 and sunny. How nice to hear from you. Let's see, who else do we have here? We have a good crew. Well, here in Windham, New Hampshire, it is currently 57 degrees. 58 degrees Fahrenheit, 54% relative humidity, and the winds are out of the west at 14 miles an hour. Manchester Airport reporting. Winds are 250 at 14, gusting 30, 10-mile visibility, broken 5,000, temperature 17, dew point 03, altimeter 29er, 57, and it has some remarks. Welcome aboard, and happy Sunday. It's been a busy week around here, but you hear that a lot, don't you? Hey, thanks for being flexible. We've totally spaced out on some of the holidays, and but we're here now, and that's what's important. We have some announcements to make this morning, and then we'll get on to the topics of the day. And if anybody has any community items, you can put them up in the chat, and we'll make sure we get to them. Let's see. The first thing is that we are going to do another McMaster-Carr catalog giveaway. One of our very nice folks, let's see, I'm going to try to get the picture here, sent us 4 McMaster-Carr catalogs, and we have the opportunity to give these away. So what we're going to do, it will be live tonight sometime. There'll be a link on the links page. It's not there yet, but it will be there tonight. At pfg.gg/links, you'll see a big button that says McMaster-Carr giveaway. You're going to hit that button. It'll take you to a, Google page, a form, and you fill out the Google form, and there's an interesting question there. You don't have to pick a number. We're not doing that anymore. And it will go on to a big spreadsheet, And then the rules are right there, and we will pick the winner on the PFG Live in, I think, 2 weeks, which, by the way, is Father's Day. So right now, even though we took Mother's Day off because I had to, I don't plan on taking Father's Day off. So we should have a live that day, and that should be the day of the giveaway. So if you're interested in a McMaster car catalog, as shown on your screen, we have a number 116, a 130, a 128, and a 127. Fill out the form. It'll be up tonight, and we will get it to you. Once again, the link is going to be pfg.gg/links, and look for a big, obvious button to enter to win. And there's zero cost associated with this. And I wanted to say a big thank you. I want to make sure I get his name right before I don't want to screw that up. To say thank you. Where is he? There he is. It's Phil Garbarini. Phil Garbarini. Thank you, Phil, for shipping me those. And if you have a McMaster car catalog you don't want and you want to ship it to me, we will give it away and I will ship it out. No cost to anyone, and it'll be wonderful. So that's one announcement for the day. Another, let's see, are we going to get to that one next, or are we going to move on a little bit here? Sam, who you have seen in some of our videos and who does some wonderful artwork and happens to be my kiddo, Sam has graduated from Tufts University, the School for the Museum of Fine Arts, graduated, done, parchment hanging on the wall. Congratulations, Sam. It's awesome. An engineer raised in Kingston says, as if on cue, the threat of rain has manifested. Well, we need a little rain every now and then, don't we? Josh says, go Sam. Tonight, in the north of the America, we're going to have some aurora. So if you get a chance to go outside and stare at the sky tonight, hopefully you got clear conditions, you might see some aurora in North America. So check it out. There was a big solar storm that basically charges the ionosphere. We actually depend on that for radio communications. And when it gets really big and strong, it will get down to the more southern latitudes, and you can actually see the aurora. So go check it out tonight. Michael Juan says, congrats to Sam. Thank you. And Ted Hyde says, well done, Sam. Thank you. And Robin says, thumb, thumb, thumb. Thank you. And Engineer Raised in Kingston also says, congrats to Sam. Thank you very much. We appreciate it. Let's see. Oh, I wanted to do a clarification. On our last PFG Live, we were talking about three-phase power, and mostly we were talking about noise generation in the shop and phase converters. And I think there was a little bit of confusion that may have crept in because we were moving at high rates of speed. There's basically three flavors of three-phase generation in the shop. I call them electronic, rotary, and static. Let me just explain the differences because I think there was a little confusion. I think people know about rotary phase converters, and that's when you take single-phase power, you run a motor with it, and the motor has 3 sets of windings on it, and you literally generate the third phase. So then off from that, you go to your three-phase delivery. That's called a rotary phase converter, and you literally have a motor sitting there running, okay? American Rotary, which bought the hotshot oven line from Stan at Bar Z. They make rotary converters that are well regarded. So that's an example of rotary phase conversion. Then there's electronic phase conversion. So this is where, again, you have single phase coming in, And then there's electronics, power electronics, that will generate the third phase. And that an example of that is Phase Perfect. That's the brand that I use, Phase Perfect converters. And that electronically generates the third phase and does a bunch of management. And the advantage of that is there's no moving parts. It's non-mechanical. It's electronic, and it makes the three-phase power. All of anything that in my shop that needs three-phase, I shouldn't say that. That's a little overstep. My grinder uses a Phase Perfect, and my vertical machining center uses a Phase Perfect. My lathe has something built in called a VFD, which is also electronic. But VFDs are a little different generally. So I have a VFD built into the Haas TL1, and there's a VFD on my Bridgeport that I put on. Those, and I've looked at the schematics, and they're pretty cool. Those take the incoming single-phase power. It actually will take single-phase or three-phase, it doesn't matter. It rectifies it to DC, and then it uses the DC to then synthesize the three-phase going out of the VFD. The advantage is they could change the frequency, and they could do acceleration and deceleration, etc. And that is in the category of electronic phase conversion. The third one, and this was a little confusing, is called a static phase converter. A static phase converter fakes the third phase using a capacitor bank, and it generates a lag in the voltage, and it makes the third leg. The problem is that it's not full power. So if you try to run a 3 horsepower motor on a static phase converter, you'll only get 2 horsepower out of it typically. I know I'm going to get cards and letters about that, but so that is a box of electronics, and I put that in air quotes because it's really capacitors and that's about maybe an inductor, and that's about it. All right, so that's a non-detailed view, but you have electronic phase conversion, rotary phase conversion, and static phase conversion. I do not recommend static phase conversion. It's cheap. That's about the only thing going for it. Okay, and if anybody has questions about that stuff, I'd be happy to research it for you, and we could look it up. I highly recommend. This is hashtag not sponsored. The Phase Perfect converters are quite nice, and they work great. I'm using them. Adam Demuth is using them. I think I saw some others in the community. Let's see. Josh. Oh, that's where I saw it. Exactly. Josh says his job uses them. So Josh's shop that he works at, I think you have 2 of them hanging on the wall, right? And they're powering some big stuff. Oh, there's one other thing about the phase converters. A VFD is typically designed to hang on one motor. Okay, it's designed to be hardwired, one VFD to one motor. Okay, that's essentially how it's supposed to be used. The phase converters, which are the rotary phase converters and the electronic phase converters, are actually power supplies. So those guys can run a bus, which runs around the shop, and you have connectors, and it could power multiple machines. It is literally a power source, and that's a difference. I have seen people using VFDs in that manner, and it's not really designed to do that. So use caution. Your mileage may vary. Not valid in all 50 states. Okay, so this we got a message here from one of our a member of our community whose name you may or may not recognize. His handle is ABomb79. ABomb79. Of course, you know who this is. This is Adam Booth, and Adam writes, because I posted the slide for today's PFG Live on Instagram, and he commented, he says, I have a topic for y'all to discuss. Just check out the comments on my post inspecting the Starrett 706 inspection blocks for height and flatness, and how wrong I was for rubbing them on my precision ground flat stones. Adam, you came to the right place. So, first of all, I have to, we're a member of the Flatstone Union, and union rules dictate that I tell you that I'm speaking for all makers of flat stones. It is perfectly correct for Adam to do what he did. I watched the video. It's exactly right. If you go to pfg.gg/stones, you will arrive at the PFG Stones product information page. And if you read it, you will find in there a discussion of using PFG Stones on gauge blocks. Okay. In fact, Starrett sells a stone for cleaning gauge blocks. Now, if Starrett sells a stone for cleaning gauge blocks, why would it be wrong to use a precision ground flat stone on a Starrett number 706 inspection block? The answer is, it's not wrong. Okay, so I'm going to do a quick demo. I have here some items. These are my 6-inch PFG stones, which I just grabbed from the grinder area down in the shop. Dale says, the biggest problem I've seen is that he's using off-brand stones. Look, I know who made his stones, okay? They're absolutely wonderful. No problem. I have full faith and confidence in his stones. Yeah, moving on. So I'm going to take my stones. I'm going to condition them, just like we teach you. And you saw Adam doing this in the video. Okay, so once your stones are conditioned, okay, we're going to use the brown one that I just conditioned. I'm just going to put it down because I can't hold everything. And then I'm going to take some gauge blocks from this box of Mitutoyo gauge blocks, which is from my shop. And I'm going to pull out the 1-inch and the 2-inch. Okay, just to show you those of you watching on video. There's my Mitutoyo 2-inch and my Mitutoyo 1-inch. And I'm going to clean them. I'm going to just clean them on my hands, on my wrist. All right, which not only is going to clean them, but it's going to leave a little tiny bit of oil as is recommended. And now I'm going to wring them together. Watch what happens. Okay. They are not ringing very well. Okay, they're ringing a little bit. Okay, but not quite good enough. So I'm going to take my 2-inch block. Okay, and I'm going to rub it on this stone. Okay, watch. 1, 2, 3, 4. I'm going to give it 5. Okay. And then I'm going to put it down. And I'm going to grab my 1-inch block. And I'm going to run it on this one. 1, 2, 3, 4. That felt good. And now I'm going to pick them back up. And I'm going to ring them together. Okay. Again. Boom. Boom. Okay. And whoops. And they're ringing. Okay. And there's nothing wrong. There's nothing wrong with doing that. Now, I'd like to explain to you in a very brief graphic term what's happening here. Okay. So I'm going to grab. I have a graphics, very advanced graphics display system here. When we have a perfectly, I'm going to take Adam off the screen for a second. When we have a perfectly flat surface, okay, and we get a scratch in it, that scratch looks like this. Okay, so you take your scriber and you run it across a flat surface. You're going to dig out some material and you're going to displace some material up above the surface. And this displacement of the material above the surface is the problem. Now, when you put something down on it, it's going to land on top of that displaced material, and that's not good. So we come along and we take our stone and we stone these guys off, and these guys disappear, and we're back to flat. We still have this scratch. There's nothing you can do about it. Even evils cannot do a weld fill on this scratch and not destroy the part. So we come along and we stone it and we get rid of these protrusions, and we end up with a flat surface again. Now, the reason that works is if we have a very flat surface and we have a very flat stone and you put them together and you rub them, what's the pounds per square inch on the metal surface? And the answer is not much, because there's lots and lots of contact. But once you have a protrusion and you put the stone down on it, the amount of contact goes way down to a little tiny point. And now how many pounds per square inch are you putting on this piece of metal that's protruding? Answer, many. All right. So that metal gets abraded. Okay. We don't like to say that when we talk about flat stones, but the metal gets abraded. But once you get back to flat again, what happens to the pounds per square inch over that metal surface? It drops way down. So that's that's the basic concept of using flat stones. So properly using a good precision ground flat stone on a precision surface, such as a gauge block, or in Adam's case, it was the Starrett 706 inspection blocks, is perfectly fine. It actually is recommended. Now, if you are not having a problem, and like, for example, on your gauge blocks, if they are ringing fine, then you don't have to do anything. You clean them, put them, ring them together, and you're off to the races. But absolutely, completely reasonable thing to do. Now, if you try to do this with a not precision ground flat stone, can you damage that surface? Yes. Okay. If you take a stone out of the box and you try to do that, you will trash your precision part. Okay. But that's why we make, and now I'm switching to a commercial, and that's why we make PFG stones, so that you can have a magnificent flat surface in the right material that sounds great to go do that with. Okay? Does anybody have any questions? I had to do that for Adam because he wasn't wrong. All right. All right. So, thank you for writing in, ABomb79. We appreciate you. Let's see, I think we covered that. Oh, so I want to talk a little bit about, process tuning first. We're going to handle that first, then we're going to handle the other topic. Because related to process tuning, now process tuning is not the same as product tuning. It's not making the thing better and better. It's making the process of making the thing better and better. For example, you saw me grab my PFG stones, and they are in a 3D printed tray. Okay, these are the old ones that had the big holes in them, and a 3D printed lid. Again, this is the old one. The new ones have black print on them. And for me, my business is not making trays and making lids, although it's critical to my business. So I have this process where all of the files to print all of my trays and all of my lids are inside the printers, and I have a spreadsheet that tells me what to do, and I work for the spreadsheet. This is my process, right? That spreadsheet has been tuned over time, so it tells me how many stones I should have in stock, how many lids I should have in stock, how many trays I should have in stock, and then it generates this little window which says, for the 3D printing department, you should go do this. For the grinding stones department, you should go do this. And I just work for the spreadsheet at that point. So I make a process, I follow the process, and then I tune the process. Well, one of the things that happened relatively recently that meant I had to tune is I was making all of the trays and the lids and such from bamboo PETG Basic. Now, you 3D printer guys probably know what I'm talking about. If you're not a 3D printer aficionado, PETG is a plastic which is in the same family as the plastic used in your 2-liter bottle of your favorite, carbonated beverage, or not carbonated. I'm not judging. It is very resistant to oils. It's very durable. It's a little less rigid. It's a little softer, but it has the right properties for what we want in a machine shop. That's why we use PETG. And I was very happy with it. Well, Bamboo decided to drop PETG and start making this PETG HF, which is high flow, which you could print very quickly compared to regular PETG. Okay, I got it. I tested it. It worked. But I didn't want to use the HF. I wanted the basic PETG, and I didn't want to pay for the extra chemicals, which they magnificently put in. So I went looking for a substitute, and I found Polymaker is the company. They make something called Polylite PETG. So I bought some. And I started printing with it, and I had issues. I had stringing and little balls of schnot being formed, and it wasn't good. So I was down to the wire. I had used up all my stock of the old stuff. I had to tune my process for a new material, and that's what I did in part this past week. One of the things I did was research on what other people recommended for tuning it. Now, why was I tuning it? So it turns out that Bamboo does have a profile for this filament, which is actually interesting because it's not their filament, but they had a profile for this filament. So I said, I'll just use their profile. Well, their profile, it wasn't working too well. So I started tweaking and changing things and going down this path. And then I said, well, what if it's not just me? What if I am dealing with wet filament? So I grab the filament and I throw it in the oven. And I set it to 150 F, which I don't remember what the science is on that. And I did a 5-hour dry. And I went back to the printer, and I still had stringing. So I kept tuning. I mean, it maybe was a little better, but I'm tuning the process, and I'm tuning the process. And finally, it was pretty good. It wasn't perfect. It still had little angel hairs, and I was like, what the heck's going on? Because I wasn't getting that with the Bamboo. So I said, you know what? I will go with that, and we'll tune it in later. Again, that process still needed tuning, but I hit go on printing. In my case, it happened to be an 8-inch lid that had to get made for an order, or to backfill from an order. And it printed, and it taught me something. Because what happened was I had 2 spools of the same material in the printer. One was the history of one of them was that I've been using it for weeks, and it was down to maybe 10 or 20% on the spool, and then the other one was full and factory fresh, but I cooked it for 5 hours with the other one. So both of these were cooked for 5 hours. When it ran out of the small amount of the weeks old filament and started on the factory fresh and baked for 5 hours filament, guess what happened? All of the stringing stopped. And I was like, dummy. So there was I kind of broke the process a little bit in that I was trusting, I was trusting that the filament came out of the bag, it was dry. I was trusting that the filament, that even though it was weeks old, it was sitting with desiccant inside the AMS. And that little difference was screwing up my process. So I had to stop and think. And one of the things that happens is and this is going to sound trivial, but it's actually not. The drying oven to dry my filament is in the shop. The 3D printers are in the basement. So there is this threshold of energy that I have to get over to pick it up, take it to the shop, dry it for N hours, which we'll talk about in a second, pick it up, go back to the 3D printers and use it. Evil says, Mr. Flat, I'm going to need you to turn in your Mr. Dry badge. Yeah, I violated my own issue here. Who is that? Because of your fancy type font, I can't quite read it. But welcome aboard, sir. We'll just call you. Is it Redfin? No, I can't read it. Well, welcome. So I have a request into my electrician to put a 220 outlet in the magic spot in my basement in the 3D printing area. I'm going to make it much shorter to travel to Rebellion Garage. Thank you very much. Rebellion Garage, welcome aboard, sir. Thanks, Robin. I'm going to make it much shorter, you lean guys like this, to get to the drying oven. So now the threshold of energy to go dry the filament is going to be lower, and now I'm more likely to do it. So then I said to myself, I said, how much does the factory now? Polymaker is packaging in aluminized Mylar bags, which are vacuum sealed. If you've been following my work on dryness, you will know that aluminized Mylar is a big plus. However, vacuum sealing is a big minus. Oh, was it a bad guess? We'll figure you out. Redskin Garage. Let's okay. Redskin Garage, welcome aboard, sir. Nice to see you. Sorry for the name confusion. So, aluminized Mylar bags, big plus. Vacuum sealing those bags, big minus. So on your screen right now in our thumbnail, I'm just going to zoom in on it here. There it is. There's the vacuum sealed aluminized Mylar bag, and you can see they sucked all the air they could out of it, and then they sealed it. The reason vacuum sealing is bad, and we're going down a little minor rabbit hole to the side here, is that there's a tendency to want to suck in stuff from the outside, right? Because now the air pressure inside the vacuum sealed bag is low, and the air pressure outside is high. So if there is a leak, and there always is a leak, it wants to push it into the bag. So we've said before, and I'll say it again, if Polymaker's listening, if Bamboo is listening, if anybody's listening, is anybody listening? Stop vacuum sealing the bags. If you leave them loose, then the differential pressure between the inside of the bag and the outside of the bag drops to zero, and there's no forcing stuff through whatever leaks there are, and there's always leaks. Okay, having said that, I asked a question, and the question is, well, if I get this aluminized Mylar, magnificent factory sealed bag, how much moisture is in it? So what I did is I took 4 rolls of the filament that I'm working with, Polymaker Polylite PETG, and I weighed them on my triple beam balance to a resolution of 1/10 of a gram. I wrote that on each of the spools. I posted a picture of this on Discord, not on Instagram. And then I baked them for 8 hours, solid, honest 8 hours at 150 F. And then I weighed them all again very quickly. And then I packaged them in my aluminized Mylar bags at zero, with zero pressure. And the result is, can I get a drum roll, please? That's not what I wanted. But the result is each of the kilogram spools had approximately 6 grams of water in it. Okay? If you are watching on video, that's what 6 grams of water looks like. Okay? So each of those spools had this much water in it from the factory in the sealed bag. Now it's a valid question. Does that matter? And the answer is, I'm not sure, but I sure want it to be the same every time. So my process. Oh, so Robin asks a great question. He says, if it leaked inward, wouldn't that seriously sucked in depression disappear that you see on your screen? The answer is, if it was gases that leaked into the bag, the bag would start relaxing and you would see that disappear. But we did an experiment and we backed it up with research, a research paper. Water molecules, of all the molecules in all the world, it had to be water. Water molecules will go through a plastic membrane. This is why the aluminum helps. And the vacuum will stay there. And we've proven this because we've taken vacuum sealed bags and shown that they will gain water. So Mr. Chin, my friend Doug Chin, he did the experiment. I gave him a couple of rolls. We measured them, baked them, and then let them sit out, all sealed. Okay, this was not aluminized. This was just plastic. And then over time, we watched them gain weight, okay, from water. And that vacuum, that little pressure, never disappeared. And when you put the knife in it, it went tss, and it sounded great. So there's a mechanism here where, if water can get through it, water's going to get through it. So my process tuning is now, everything gets baked. Okay, my laziness is over. If a spool of filament comes into the shop, it's going in the oven, and I will always get the same thing every time. I think the manufacturers are pretty good at delivering us filament, which is the same every time. They're pretty good at that. The plastics guys know what they're doing. What says the material is dry when they package it? Nothing says the material is dry when they package it. That's a very good question. So one of the things that I asked, and I forget who I was talking to, when they package them at the factory, My concern is that it's going on a big bulk spool, and then it's going off to be spooled off into the smaller spools, and we don't know how long that would sit on the big bulk spool. That was my picture in my head. It turns out it's not true. It literally comes out of the extruder, and then it goes on to these spools. However, I've heard stories of the use of water to cool the plastic as it comes out to go on the spool. So there is absolutely a possibility that the spooled filament from the factory is not dry. And when I say is not dry, I mean is not dry to our specifications. But if you dry every one that comes in, it resets the counter every time. So you know what you have. And that's the message in this particular process tuning, is that I'm going to eliminate a variable. And now it can come in an aluminized Mylar bag. It can come in a non-aluminized plastic bag. It could come in vacuum packed. It could come in non-vacuum packed. I've had filament come in that's supposed to be vacuum packed, but it sprung a leak and it wasn't vacuum packed. It goes right into the oven. So there you go. I mean, right? 6 grams of water. That's what it looks like. Would you put that in your roll of filament before using it? I sure don't want it. So, what do you need in order to have a process to tune? You need to have process parameters. And, for me, in my production process, it's my spreadsheet. In my printing process, for example, it's my G code. It's how I handle the filament, which of course now is getting modified and tightened. So the message is have a process and then adjust the process as necessary. Here's the rest of the story: once I nailed that down and I realized, oh, this stuff needs drying, the prints started coming out like you read about, and they were perfect. So now I have a very nice profile for that filament, and I don't have to think about it anymore. So Dale, WidgetWorks, says, I have seen the process. That's right. So Dale, let me explain. Dale has a neighbor in Edmonton that has a business of making filament. Okay. And I think he only makes PLA and PETG right now. But Dale says, I have seen the process. It comes right out of the extruder, straight into a water bath trough, and then onto a spool. So if you were wondering, that is reality. And Dale's eyeballs have seen it. And Evil says, quote, without standardization, there is no improvement, close quote, as the lean guys say. Yeah, this is one of the things that the lean guys teach us. A friend of mine says, you should always, this is my friend Dave. He says, you should always have a plan from which you can deviate. Robin suggests that your buddy who's doing the manufacturing switches to liquid nitrogen to cool the filament, which, who could argue with that? From the pellets back to the pellets. That's what I say. Nathan Jaffrey, welcome aboard, sir. He says, first-time viewer. Awesome to hear some of your insights on your processes. As a 3D printing hobbyist, I definitely get frustrated with poor filament quality control. Sir, hear me now, believe me later. I think 80%, and that might be conservative, I think 80% of all the printing issues goes away if you dry your filament. I hear so much of this. My first layer won't stick. My first layer gets blobby. My first layer, it looks like this. It used to look like this. It doesn't. I am a firm believer. And oh, by the way, if you know, and I'm gonna this is my last call on this topic. If you know somebody in the injection molding business, go visit them. because those guys know. They get material in pellets, and they have machines. And you know what the machines do? It heats the pellets. It's the same exact problem. And if you said to the guy in the injection molding business, why don't you stop heating the pellets? You'll save all sorts of money. He will look at you funny. Thank you, Dale. Dale put a picture up of an extrusion line. Yeah, Robin says same issue with vacuum forming. Sure. It's all about the plastics. I was telling Carl earlier that, you know, I said I was bemoaning this over dinner. I said, it's, you know, this is PETG and this is PETG. And this one works great and this one doesn't work great. And I have to tune this one. And she says to me, yeah, that's because they're polymers. And that polymer, they might be the same, chemically the same polymer, but some of the polymer chains are longer and some are going to be shorter. And it's a probability distribution function. And it could be bimodal and it could have different lengths. And I'm like, whoa, time out. How about I just dry my filament? So even though it says PETG on the label, you have to tune your process. Even though it's 1018 steel from this supplier versus this supplier, you have to tune your process. Even though it's 52-100 magnificent bearing steel, which I love, it depends who it comes from. And if you need to know, now Dale will tell us, right? If you need to know that alloy that you're getting is not only that alloy, it's exactly this, you will pay for it. What was the name of that stuff you were getting? It's not necessarily a process issue, but you were getting it. Was it Vespel, Dale? Yes. Dale had a customer come in and he had to make parts with Vespel, which is a plastic. It's a very interesting plastic. And he goes to price the stuff, and I think it was it 1.5 inches? What was the diameter of that rod? Maybe it was 3-inch diameter, 2-inch diameter. And we looked it up, and don't give it away. But what was the dollar amount in the units we were looking at? I think it was, yeah, $540. Anybody want to guess the linear unit that $540 applied to in a 2-inch diameter? Robin got it, per inch. 2-inch diameter, $540 per inch. So here we are with our 3D printers. Dry your filament and you bring that sucker right down to 0, and at least you remove a variable that you do not have to deal with the next time you put in a new roll of filament. And I said all that so that I could watch this again and remind myself to dry the damn filament. All right. Moving on. Sometimes you don't get to quit at P1, right? You get a project, you're going to make a prototype. And we have come up with these magnificent sayings. In fact, there's our sticker on the sticker board, right there. And it says in Latin, it says 15 minutes is all we need. Oh, there's a good YouTube video that Evils is putting up. Cool. Thank you, Evils. It's about knife steels and compositions and control. So we joke about this, that you make P1 and all P1 has to just last 15 minutes. Oh, there's the Vespel parts. Dale just posted the picture. That is not a cheap part right there. The banana is cheap, but the other one's not cheap. So when we started talking about P1 and it has to last 15 minutes, the whole idea is that you have to make something from which you can move on from. And Robin, actually, this is actually apropos of Vespel, right? Robin says, well, what about if you do a design in in Fusion or your favorite CAD program, and you iterate in CAD, does that count as P1, P2, P3? And I think we just by definition we said no, we're talking about a hardware prototype. But it got me thinking, and I think it's worth saying that there are some things where making prototypes is inexpensive. Okay, if you're making a 3D printed part, here's a case in point. I don't have to go very far. I needed to make a cap, right? I needed to make a cap that replaces this blue cap, right? That was cheaper so that I could put it on this very expensive RF connector for painting of a thing. It happens to be the gold-colored thing in the picture here. So I made these. Well, guess what? The first time I made these, and it should have fit perfectly. Do you think it fit perfectly? No, it didn't fit perfectly. So I go on to P2 and I make it. How much did it cost me to make this PLA Pro cap? Pennies. Very little. But what if you were Dale and your customer says, I need this stuff in Vespel. Are you going to go try it in Vespel to tune your cutting parameters and then throw it away? Because, once you've got P1 done, you could move on. I don't think so. Not at $3,000 to do what he just did there in that picture. And that's what he says. It costs $3,000 to make that part. So sometimes P1 has to equal R1, which is, the released version. And when that happens, yes, you're going to spend time on CAD, and you're going to spend time in simulation. So there are simulation tools which you can use to exercise your parts to make sure they're meeting certain parameters and certain, for certain fits and such, before you ever cut a piece of metal, plastic, brass, Vespel, whatever. And that is appropriate when it's a very expensive material or a very expensive process. Who was it that recently was making stuff out of gold? And there was like a reason. I think it was a physics thing. They had to make some parts out of gold. Stefan Gottsvinter. So, yeah, he had to make some parts out of gold. So he was actually kind of, okay, blasé with the whole thing. But the fact of the matter is you're not going to go to your customer and say, yeah, we'll make a couple, and if they don't work out, we'll throw them away when the material is gold. Although Vespel is more expensive than gold. At least gold you can melt down and reuse. Yeah, okay. We said the same thing, Evils. Gold is infinitely recyclable where Vespel is not. So I have this project where I'm doing this RF processing thing, and because of the nature of the beast, we didn't have a lot of prototyping cycles available. And I sort of declared that R1 equals P1. So it had to be right. So not only was CAD, design and fit and all that kind of stuff important, but electromagnetic simulation was very important. So that product was designed and then brought into electromagnetic simulation and then tweaked inside of the electromagnetic simulations. And then those changes that came out of electromagnetic simulations went back to CAD. And then, until all the computers agreed that this thing was as close to perfect as you can get, because we wanted P1 to equal R1 in this case. If I was that worked up about making this little plastic cap and having P1 equal R1, that would be kind of stupid, because it's like, just get it done. Yes, so Robin brings up a good point, and that is, well, let me do this as a story, right? If I said to you, I need a dozen eggs, would you please go to the store and get a dozen eggs. Okay? How many people would, well, first draw the route to the store and measure it, calculate the fuel efficiency of the vehicle you're going to use, measure how much fuel is available, calculate the cost of the fuel, double check that the cost was acceptable as a trade-off versus the cost of the eggs. Yeah, Evils would. I know that. That's not the point. Yeah, Evil says, I know my route, I know how long it is, and I buy the fuel there. Okay. So the point, the eggs are the fuel. The point is that you're looking at me crazy, like, what are you talking about? I'm going to get in my car. I'm going to drive down to the supermarket. I'm going to buy a dozen eggs. As long as I remembered my wallet, I'm going to come home. Mission accomplished. So to you, the thought of getting in your car, driving to the store, and driving back is like, that's trivial, right? But what if you're you just turned 16 and you didn't get or you just got your learner's permit, right? You're not comfortable with this yet. And all of a sudden, a whole bunch of brain cycles is going into a lot of minutia. So Robin says your experience trumps all the other aspects, and that's true. If you're an expert, and
I am not an expert.
But if you were an expert, you could move ahead on some things that other people might have to stop and slow down. So, if I need a spindle that has 1 nanometer run out, I know who to go to. And I'm going to go to Robin. And Robin and I could stand in his shop and talk about the Red Sox while he's making the 1 nanometer spindle, and it's going to be fine. If you came to me for a 1 nanometer spindle, I would need therapy first. Okay. So, in my case, with this RF thing, I understood and spoke the language, and I've been doing it for 25 years. So, same thing. The experience matters, but using the tools matter. And finally, R1 equals P1. Evil says it's probably easier to get the 1 nanometer TIR when the operator is relaxed. Yes, this is true. So the cost of making the thing is a major input. The experience of the artisan is a major input. If we look at what SpaceX did with rockets, people were aghast that they would design the rocket and very quickly go to launch the rocket. And in their mind, they're like, no, this is P1. This is absolutely worth doing as P1. We know it's going to go 100 feet in the air and it's going to blow up, because we're going to get very valuable data about that 100 feet. And it's totally worth it. To them, that launch was this plastic cap. To you, that launch might not have been this plastic cap. So they do that calculation and they go P1, P2, P3. Okay, we got it. Whereas another organization might choose to say, oh no, when we push the green button, it's got to be correct. And that's a whole other approach. And when we've never done it before, yeah, everybody's nervous. Nobody's relaxed, Evils. Nobody has experience, Robin. Everybody's like biting on their nails. And it takes time and money and simulation and, oh my gosh, are we going to actually do this? And they finally do it. So there's a cost of making prototypes that is human. There's a cost of making prototypes that is monetary. And it's not easy. One of these days, when this project, that gold box there, when this project is over, I have stories to tell you, but I can't do it yet. Here's the punchline, because we're coming up on the top of the hour. The punchline of that project is that I was putting together physically putting together that first unit, the first article, when my customer called me. And I said, and we were on, a video capable medium. And my customer called me and said, "Hey, how's it going?" And I said, "Well, I'm about to observe the first unit. Like, we'd never looked at it on the instruments before." And I said, "Hang out with us." And I set him up on a tripod, and I literally got what we call first light of this project while the customer was live. And you know what? It worked great. Met all specifications, and it was awesome. So that was a case of biting the nails, doing all the simulations, making sure it gets right the first time. There you go. So Robin says, that is why $ expensive consulting hours can be worth the expense. It removes a lot of wasted time and money. 100%. Of course, I have to agree with you, Robin, because I'm in the consultants union. So, but it's true. Okay, I'll tell you one more story, and then we'll wrap it up. I get a call one day. This story I actually wrote as an article in my blog. It's very old, okay? But I get a call one day from a company making a medical related device. It was a radio, a transmitter. I think I could talk about that. It's been enough decades. It was measuring blood sugar through a transdermal method, which I don't say this disrespectfully. I don't care about. I'm the antenna guy. So, and they had this little puck, and they said, the guy says, "Yeah, our receiver has to be almost on the patient's belly to get the signal out of this thing." And I'm like, something ain't right. I said, "Okay." So we signed all the papers. He said, "Come on over." So he comes over to my lab, and he said, he gives me this thing, and I open it up, and it's operating at 900 megahertz. And I look at this thing, and I literally said to him, "Who designed the antenna?" He said, "I did." And it was structurally, it was what we would call a folded dipole. Okay. And I said, "Okay, how did you calculate the length of this wire?" And he said, "Oh, I did the calculation, and I made it 1/2 wavelength." And I said, "Excuse me?" He says, "I made it 1/2 wavelength." So immediately I knew that the singularly worst value that he could have said was 1/2 wavelength. So we hooked this thing up. I have a spectrum analyzer over here. We're listening to this thing transmit its puny weak signal, and we got this little tiny bitty signal on the spectrum analyzer. And I pick up a pair of wire cutters, and he's sitting right here. He's sitting right on my right. And I reach down, and I go to the center of that wire, and I go snip, and the signal on the spectrum analyzer jumps up 30 dB. He says, "Well, what did you do?" I'm like, "You picked the exact wrong value." And I just changed it from a folded dipole to a dipole. And now it's the correct length of wire for a regular dipole. Anyway, I called that episode 30 dB in 30 minutes. And that is my best illustration of what Robin just says, is that, I charge a lot of money per hour as a consultant, but in 30 minutes, I completely fixed this guy's product. Long story short, that product went off to clinical trials. They were successful in doing what they had to do, and we were done. That was probably one of the clients that spent the least amount of money with me. But I knew what I was looking at. All right. That wasn't about me. That was about the cost of prototyping and listening to experts to reduce the cost of prototyping. Okay. So let's see if we hit all the main points. Just a reminder that we're going to be doing the McMaster Car Catalog giveaway tonight before my head hits the pillow. There'll be a link on the pfg.gg/links page, and you'll be able to enter. That'll be up for 2 weeks. If you want one of those magnificent McMaster Car catalogs, we'll get it out to you. What else? We did that. We talked about the Aurora tonight. That's time sensitive. And yeah, we did all the things. If you guys have any questions or topics, pass them along. You can reach us at the contact page on the PFG Stones website, which is the same as pfg.gg. And let's see, we had one other comment in here. Engineer raised in Kingston says, somewhat tangential, but the best way to see the need for filament drying is printing PA6HT. That's, if I got this right, that's nylon, high temperature, without drying. Learned that the hard and expensive way. Yeah, absolutely true. Also, if you print filament and you see it spitting and bursts of steam coming out of the nozzle, it's kind of a giveaway. Don't you think? If you're able to join us in the after-party roundtable, once we're done here, we usually hang out there for the better part of an hour and talk. You're welcome to do that. Join us on Discord. If you'd like to join our Discord server, head over to pfg.gg/Discord. Bet you didn't see that coming. And you can join us there. If you don't have a set of PFG Stones, go get yourself a set. Head over to pfg.gg/stones and learn all about it. In the meantime, have yourselves an awesome week. We'll see you next week with a guest. See, nobody reminded me. We're going to have Adam Balog on of Laney Machine Works. Laney Machine Tech. And Adam is an awesome educator and does fantastic work with his students. And he has agreed to come on January 8th. So if the creek don't rise, we'll see him on January 8th. And we'll see you on January 8th. And in the meantime, get flat, stay flat, and we'll see you soon.